Now we'll discuss the topic capacitance of a conductor. Now till now we already know that conductors have certain electrostatic properties. But today we'll come to know that conductors can also store charge. Now let us suppose there is a conductor, and if you are trying to give certain charge to the conductor, what happens is it would start to increase the potential. This increase of potential or this rising of the potential as you give the charge for a conductor to hold is very proportional in nature to each other. It means the more you give the charge, the potential difference would slowly increase. So you can write from this equation Q equal to CV, where Q is the given charge, C is the proportionality constant, and V is the increment or the raise of the potential difference while you have given a charge Q. This quantity C is also called the capacitance of the conductor. If you want to find the capacitance, which is equal to Q by V, we can define a capacitance in a way that it is the rise of the potential due to the Q amount of charge given. So capacitance generally gives us the information as to how much of charge a conductor can hold, right? So if you just put its formulas, suppose I give 1 coulomb of charge and it has risen 1 volt of potential difference, then the capacitance would be 1 coulomb per volt. So this capacitance, which is 1 coulomb per volt, is also called 1 farad or 1 F. So from here you know that the SI unit of capacitance is called farad. The symbol is F, which is equal to 1 coulomb per volt. This quantity, capacitance, necessarily tells us as to how much of charge a conductor can store inside it when it is rising its potential to an amount of V. This quantity capacitance depend on certain factors like the size or the shape of the conductor. Also, if there are certain dielectric medias are present or not. Also, it depends if there are any other conductors present nearby or not. Now, generally, if you have a conductor, you can store certain amount of charge inside it, right? But suppose if you have two conductors or suppose I have two parallel metal plate conductors, then these two conductors can store more amount of charge. From here we would also see that this type of system where we are trying to take two conductors and sandwiching them in between with certain dielectric medium. Dielectric mediums are necessarily a non-conducting medium that we have already seen. So when we take two conductors and sandwich it with a dielectric medium, this type of system we call them as a capacitor. This capacitor generally can store large amount of charge, and therefore their capacity of storing charge, which is the capacitance, would be quite high. And we will see as to how certain type of capacitor can store amount of charge inside. So now we will start with little discussion on capacitor. As you remember, we were discussing that suppose if we take two conductors and sandwich it with or fill it with a certain dielectric medium, then this system is called a capacitor. Generally what happens is both this charge conductor, both these conductors would be given certain amount of charge. Let's suppose we give them charge Q. So this plate or this side has a plus charge, this side has a minus charge Q, which is same amount but opposite charges. So the inner side of this conductor would have all the charge, plus charge region, and this side is minus charge region. Therefore, there is an electric field which is directing from positive to the negative side. Now, if I want to give more charge, or if I want to increase the capacity of such capacitor, because generally every time we try to find a capacitor which can store more charges. So if I have to store more charge, I have to increase the capacitance of that capacitor. As we know, capacitance is equal to Q by V. So if your capacitance has to be constant, then if you give more charge to it, generally what happens? Your potential also starts to increase for a particular constant capacitance. But if we see that if potential starts to increase, then there is a mishap happens and there is a leakage. Rather than storing of charge inside the capacitor, there is a leakage of charge starts to happen. How does it happen? If we give more charge, if we increase more charge, keeping the capacitance constant of the capacitor, it will increase the potential difference in it. So as you give more charge, capacitance is constant, it will definitely increase the potential inside. If the potential increases, it means that the electric field inside would also increase. And if this electric field starts to increase, the surrounding media of this capacitor would start to ionize. As the media starts to ionize, this charges generally get neutralizes, and when it gets neutralized, and also there are extra amount of charge, this charges starts to leak from this boundary. It means that this dielectric media loses its property of dielectricity, or it loses the property of non-transferring or non-conducting the charge. So therefore there is a breakdown which is happened, which results in leakage of the charge. So what we see, if you keep the capacitance constant and start to give lot of charge to this same capacitor, it would start to increase in its potential difference, which will in turn increase the electric field inside it. This electric field will ionize the medium surrounding it, and this ionization process would break down the dielectric strength of this dielectric media, and then the excess charge would start to leak through the conductor. Therefore, we cannot keep increasing the charge to a capacitor, to give a charge to the capacitor, while allowing the potential to increase. This is a very unpredictable, or it's a very difficult process, because it is leading to a leakage. What we can do is, we have to make sure that voltage difference, potential difference is always kept in a low, or we can say that the electric field should be always to a certain limit. How much is the limit? Limit of the electric field should be 3 into 10 power 6 volt per meter, so that the ionization doesn't take place and the dielectric breakdown doesn't take place. So if the electric field is below 3 into 10 power 6 volt per meter, then no leakage takes place and it is fine, and the capacitor can hold the charge. But if you keep on giving the charge to the same capacitor without increasing its capacitance, then the voltage, the potential difference would actually increase, but we cannot allow that. So the electric field cannot increase more than 3 into 10 power 6 volt per meter. So therefore, to increase the capacity of the capacitors, we generally give certain charges keeping the potential difference very low. When we give the charge, we try to keep the potential difference at very low, and we try to see that electric field does not cross this value, and therefore the dielectric breakdown doesn't happen and there is no leakage happening. Rather than leakage, there is a storage of electric charges happening in the capacitor. So the capacitor would work based on this kind of process.